Hi everyone, thanks for clicking and welcome back to my channel. Today, we'll be covering a very interesting topic, one which confuses many pilots. RNAV and RNP approaches, are they precision or non-precision? And we'll also be answering the mysterious question, what is the difference between RNAV and RNP? Well, stick around to find out. Before we get started, kindly consider helping the channel grow by subscribing should you find the video helpful. So without any further ado, let's get right into it. Alright, let's do a quick recap before we dig deeper. A precision approach is one that provides both lateral and vertical guidance, such as the most common one, the ILS, or Instrument Landing System, which broadcasts two lobes signals in both azimuth as well as the vertical path to help guide the aircraft down to the threshold. Also, we have MLS, Micro Landing System, not in use anymore, but in service. There is also PIR, or the Precision Approach Radar, usually used by the military, though civilians may also use it. And last but not least, the newest GLS, or GBAS landing system. I will make a video about the GLS and how it works in a separate video soon. On the other hand, however, non-precision approaches provide only the lateral guidance. It is up to the pilot flying to determine the appropriate rate of descent to maintain the proper vertical profile. For example, we have NDB, non-directional beacon, VOR, very high frequency omnidirectional range. We have RNAV, LNAV only approach, LDA, localizer only, and so on. These are the non-precision approaches. Now, prelude to understanding this topic once and for all, let's see what is the difference between RNAV and RNP. Assuming you guys already know what RNAV or area navigation is, I will go ahead simply and answer the question. RNP, or Required Navigation Performance, is a type of RNAV itself. However, for an RNAV system to be considered an RNP, two important rules must be met. First, RNP is a PBN system, or performance-based navigation, that includes onboard monitoring and alerting capability, such as RAIN, or Receiver Autonomous Integrity Monitoring. Let me simplify this a bit more. An RNAV standalone system does not incorporate any capability to alert the pilot if the accuracy degrades over time, or for whatever reason it becomes inaccurate. RNP, on the other hand, does. It monitors the required accuracy according to the phase of the flight we are in and notifies the pilot if there is any discrepancy or degrading accuracy. Okay? There is a second difference, which is that RNP must meet the specified accuracy at least 95% of the flight time. Meaning, say we are on the arrival phase, for example, with RNP1 accuracy. By the way, RNP1 means RNP accuracy of 1 nautical mile off-track deviation. Okay? That at least 95% of the time, of the flight time, the aircraft is capable of meeting this accuracy. Okay? So let's sum up what we have just said for better understanding. RNAV, or area navigation, does not have any capability to notify the pilots if the accuracy degrades or it becomes uncertain of its current position. This raises an issue, especially when we would like to fly RNAV approaches in congested airspace. So they came up with an enhancement with two important features. First is the capability to monitor and alert the crew. Plus, RNAV must meet the specified accuracy associated with the phase of the flight, at least 95% of the flight time. When these two requirements are met, this system then becomes an RNP, or Required Navigation Performance. Let me give you an example. The IRS, or the Inertial Reference System, those ring laser gyros, they start from a known position and with time their accuracy degrades. Yet there is no alert made to the pilots. We don't know how accurate the system or the navigation is. This is an RNAV system. Okay? The RAIN, or SBAS, a satellite-based augmentation system, such as the WAAS, Wide Area Augmentation System, used in the United States, or the IGNOS, used in Europe, when the signal is lost or the accuracy deteriorates, it gives you a notification. This is an RNP. Alright guys? Trust me, it does not get any simpler than this. Now that we understand what is the difference between RNAV and RNP, let's talk about RNAV and RNP approaches. I have started this video by a quick recap about precision and non-precision approaches. In fact, there is one more category in instrument approaches that falls in between those two. This category incorporates approaches which are more accurate or precise than non-precision approaches, yet slightly or negligibly less precise to be considered as precision approaches, even though it is not the case, and I will explain the reason shortly. This category is named APV, or approaches with vertical guidance. Under this category, we can find LPV, or localized performance with vertical guidance. This type of approach is an RNP approach. It provides you both lateral and vertical guidance and can take you down to as low as 200 feet above aerodrome level. It is as accurate as an ILS, yet it is not considered a precision approach. It is an APV approach. Okay? Now, to be able to fly an LPV, your aircraft requires an S-band receiver as well as an S-band coverage in the area of intended operation. Okay? Meaning, just because you're having an S-band on your aircraft, you cannot fly an LPV in airports where there is no coverage, geo-satellite coverage. Okay? So, basic GPS or barrel VNAV system won't work. Next, LNAV VNAV. It is also an APV approach. As the name denotes, it provides both lateral and vertical guidance. There are two major differences between LNAV VNAV approach and LPV approach. Is that firstly, the sensitivity of LPV increases as we get closer to the threshold. Thus, it is more accurate. And normally the decision height associated with LPVs is usually 200 feet above aerodrome level, so as low as an ILS Cat 1. LNAV VNAV does not, meaning the sensitivity does not increase. It remains almost constant. This is why the minimums or decision height of LNAV VNAV are higher than those of LPV. This is the first difference. The second difference is you don't need an S-band receiver to shoot an LNAV VNAV approach. Barrel VNAV system will do. Okay? This table will help you visualize the equipment and the associated approach we can fly. Okay? Alright, ladies and gentlemen, this brings us to the end of this video. If you have any questions or suggestions, kindly feel free to leave them in the comment section below. I'll be more than happy to answer you guys. And until the next video, see ya.